Hey guys, welcome back to my channel. Today I'm going to be talking about the root test. So the root test helps us determine as to whether a series converges or diverges. So say we have a series that looks something like this, right? We have a series and we want to know if it converges or diverges. So we have to look at the limit. The limit as n goes to infinity, and then there's like a root, right? And then we have to find the absolute value of an, right? So absolute value of an, and then we want to know as to whether this series converges or diverges. So we have to evaluate the limit, and so we have some cases, 3 cases. So if the limit is less than 1, then that means that the series is absolutely convergent. And when the series is absolutely convergent, it means that the absolute value, right? The absolute value of this, so this is going to be convergent. That's what it means if the series is absolutely convergent. So that's when the limit is less than 1. Now, when something is absolutely convergent, it just basically means that the original series itself is convergent. So we can also say that the original series is therefore convergent. So this original series is going to be convergent if the limit is less than 1. Because if something is absolutely convergent, it will be convergent. Now, if the limit, however, is greater than 1, or if the limit is equal to infinity, then that would mean that the series is divergent. So that would mean that here it's convergent, right? Here it's going to make the series divergent. Okay? And then now, if the limit, however, is equal to 1, then that would mean that the test is inconclusive, and that means we have to use a different test. Conclusive, use other test. So it's very similar to the ratio test. Same cases, right? Same cases, so like if it's less than 1, convergent, like absolutely convergent and convergent. If it's greater than 1 or equal to infinity, it's going to be divergent, and if it's equal to 1, it's inconclusive. We have to use a different test, very similar to the ratio test. Now, if you do get the limit being equal to 1, and then you think, oh, I have to use a different test, let's use the ratio test. No, that's not a great idea. No, don't do that, because you're going to also get the L being equal to 1 if you use the ratio test. Same with the ratio test. If you get the L being equal to 1 in the ratio test, you're like, oh, I should probably use the root test. No, don't do that, because the L is just going to be equal to 1 for the root test as well. So you can see how these tests are kind of linked in some way. So now let's dive down into an example. So say we have a series that looks something like this, and we want to determine as to whether it converges or diverges. So let's look at the limit. Let's evaluate the limit. So limit n goes to infinity, and according to a root test, well, the root test, we have this root here, right? An, absolute value of an, okay, right? Root test, there's a root, okay, you can see that. That's why the name's called root test. Anyways, and so now we just have to plug in this whole thing for an, right? Our an is going to be equal to this whole thing. An is equal to this whole thing right here. Don't forget these exponents. This is our an right here. So we just have to plug that in to this, to the part where we see an in this limit. So it's going to be a root here, and then the absolute value of an is going to be an absolute value of 3n plus 4 over 3 plus n to the exponent of 2n, okay? And then what we do next is we can see that we have an n in here, right? Okay, so now we have an n here, right? So we can rewrite this according to exponent laws. We can rewrite this as, we can copy everything in here, squared, right? Can basically rewrite this whole thing with a bracket here and the n here and then absolute value sign, right? We know that we can multiply these two exponents together to get 2n, right? It's using exponent laws. So we want to know as to where we can take this n outside of the absolute value. So let's put brackets around here. So it's kind of like we have something inside these brackets, right, with the exponent of n. So we want to know if we can do this. We can take this n out. Now, look at what's inside the brackets. Here we have 3n plus 4, 3 plus n, and remember, n can be from 1 to infinity, right? It's going to make this whole thing positive. Even with a square, it's just going to make it positive. So we have this thing being positive, okay? So let's say, so we don't have to really consider if the number is negative, but think of it this way. Let's say we have a positive number, okay, inside the brackets, and let's say it's like 4, okay? Let's say it's 4, okay? That's being inside the brackets, okay? And we have 4, and it's to the exponent of n, so say that n is equal to, let's say, 3, okay? So this here is surrounded by the bold brackets, right? Bold brackets that I make here. So it's to the exponent of 3, and there's absolute value signs around it. And then it's the cube root, because pretend n is equal to 3. Okay, so think of it this way. It's just like considering an easier example on the side. So if we find the absolute value of 4 to the exponent of 3, it's going to be 64. It's surrounded by absolute value signs, and then 3, like right this cube root, 64, absolute value of 64 is just going to be 64, and the cube root of this is just going to be 4. Now, similarly, let's consider, say, that the n being outside of the absolute value sign, right? So we have the absolute value sign, we have 4 in here, right? 4 is this whole thing inside the bold brackets, okay? So let's say we take that n out, put it here, and we are going to get, so our n is 3, so this is 3, so let's rewrite this as 3. So 3 and 3, right, they're going to cancel out after, but let's actually look at it this case. So we have a 3 here. So here in this case, the absolute value of 4 is going to be 4. So we're going to get 4, right? Absolute value of 4 is going to be 4. And it's going to be to the exponent of 3. And hey, is this going to cancel out again? Right, it's going to be 4. Because the cube root and this to the exponent of 3 cancel out. Why do we use positive numbers in this case? Well, because whatever's in here is just going to be positive, right? Because it's squared, okay? So we're just considering the cases with positive numbers, and hey, look, it's the exact same thing. We get the exact same thing. And so getting the exact same thing tells us we can take this n outside of the absolute value, right? Just to show like why we can do this as an easier example. So let's take out the n from the absolute value sign. Because why do we need to take it out of the absolute value sign? So we can cancel it with this root, right? This root. And so let's do that. So it's going to be 3n plus 4 over 3 plus n squared. And the n is going to be taken out of the absolute value sign like this, and then so this n and this root n is going to cancel, so we are going to be left with this, right, the absolute value sign. We technically don't need to write it, the absolute value sign, and that is because of the fact that this whole thing, as mentioned before, is positive, and that's because we have a square right here. this whole thing is positive. So since this whole thing is positive, we don't need the absolute value sign. So I'm going to get rid of the absolute values so we can make it look simpler. There we go. And then now we can evaluate this limit. So using the properties of limit, we know that we can evaluate this limit. We can bring it inside the brackets. Just evaluate whatever is inside the brackets. 3 plus n like this, squared. So let's evaluate what's inside the brackets. Okay, well, evaluating the limit for this, we know that if we plug in infinity to the top and to the bottom for n, it's just this whole thing's going to go to infinity, and so is the denominator. Numerator is going to infinity, right? Denominator is going to infinity. We need to use L'Hopital's rule. And doing that, we have to differentiate the top and bottom. So I'm going to do that. Differentiating the top, we get 3, right? So this is to the exponent of 1, so we'll bring that down, power rule. For derivatives, and then 4 is a constant, so it becomes just 0, right? And here is a constant, it becomes 0. And this n here, it's going to just be 1, okay? And we square this, and the limit of this is just going to be 3, right? Because there's no n anywhere, so it's just going to be 3 over 1, right? 3 over 1 is just 3, so this whole thing squared. And then we are going to get 9. The end. And here in this case, 9 is greater than 1, so therefore this makes the series divergent. So therefore the series is divergent. So therefore the series is divergent by the root test. Okay, so this is the end of my video. I hope you enjoyed it and I hope it helped. Feel free to leave a comment down below what you think about it, and furthermore, if you enjoy my content, feel free to subscribe if you haven't done so already, and also, if you like this video, feel free to give it a thumbs up. Thank you for joining me once again, and I hope to see you in another one of my fun math videos. Bye!